Hi, I'm Bob with LPS Computer. Today I'm going to show you how to make weapons-grade plutonium from things you probably already have in your garage or that you can easily get down to local auto parts. Oh, what's that? Oh, that's tomorrow? Sorry. Today we're going to work on the Designjet 5000, 5500. We're going to replace the carriage belts in it. And what we're going to be using is the instructions from a kit that's supplied by LPS Computer. The instructions are several pages of illustrated step-by-step instructions to make it relatively easy to do this job. Along with the instructions, there is the complete Hewlett-Packard service manual with the all of the replacement procedures for everything in the machine. There's troubleshooting guide, parts catalog, all that kind of stuff, error codes. Okay, we also have a 39-piece toolkit that comes with it. It's got all the assorted Torx bits that you'll need and socket wrenches. And there are also a couple of extended Torx. These are specialty kind of tools. One of these we'll be using for the replacement today. The other one is for another job you may possibly want to do down the road. In any case, all the tools you could ever need to repair this machine are here. And of course, there's the belt in the kit. These belts are made in the United States on molds made in the United States, all owned by LPS Computer. The belts are, I've got one out here, the belts are made out of high-density polyurethane and DuPont Kevlar. The belts are identical to the HPs functionally. The only difference you might notice is that the splices on them are of a different design. They're very strong. The belts are put together to a standard of 40 thousandths plus or minus, 40 thousandths of an inch plus or minus. And they're made specifically for these machines. All the other belts in the world come from Asia. These are the only ones made in the United States, as I said. And the HP belts are, fine quality, no problem there. They're made of the same materials these are, and they come from Singapore. The other belts are not high-density polyurethane. They're neoprene. We've bought them, we've cut them apart, we've tested them in a number of ways. They're neoprene and fiberglass. It's an ancient technology, and we've had some real sad stories come to us over the past year or two with them. Just last week, somebody called and said their belt started coming apart after the second plot. Other people called and said they're too long, they're too short. The quality control is just not there. But we guarantee these belts to give you no trouble, just great service, and to run very smoothly. The kit also has non-evaporating oil. This is kind of an important little item because the rails that the carriage travel on do not have equal friction left and right. So the machine calibrates the motor to run at the same speed, and it does that by creating some voltage offsets left and right. Kit also comes with plastic calibration media. The reason we like this is because it's thermally stable. It won't expand or contract from being touched by your hands like paper will. And it's also very stable as far as humidity in the air or from being printed on. Hewlett-Packard used to provide this material for calibration, but several years ago they stopped doing that, more like 10 years ago. And I suspect it's because the sheet material became unavailable. We've been buying it by the roll, and we have it cut for us because we really believe and we know from our own experience if you're going to get the maximum accuracy on your calibration, you need to have a very stable material to print the patterns on. So we use this, and we use it ourselves with all of our customers, and we put it in the kit. That's about all I've got on the kit. Let's go ahead and start taking this machine apart, and I'll show you how to replace the belt. First thing we have to do is take off both end covers. The left end cover, first thing we have to do is take out the inks here. We'll take those out and set them aside. And the reason we need to do this is because the ink supply side of the ink tube system needs to come out first so we can get this cover off. I'll swing this around and show you what I mean. Okay, this is the end of the ink supply end of the tube system here. We've got a air pressure hose that gets disconnected by pushing this little silver button. We need to take this ribbon cable out by pinching it on the sides and pulling it out. And this screw needs to come out because it's attached to the cover itself. So I'll go ahead and take that out. Get it out of the way. And now this assembly is ready to slide out the back. Turn each of these latches or these levers, rotate them counterclockwise a little bit, and this will slide out. Now what I usually do is just open the top lid and set it inside the top lid where it's out of the way for now. We are going to take the entire tube system out though. Okay, there are a total of 6 screws holding this all together. There's one up in this corner. There's one down bottom corner. Probably didn't catch that on the camera. And there are 4 in the front. They're located here. 1, 2, 3, 4. So I'm going to go ahead and remove those 4 screws, and this cover will slide off. Took some of these screws out ahead of time so we don't waste your time so much. Okay, that one's off. We'll set that aside. This cover's a little bit easier. You've got the same 4 screws. One of them's underneath the blue lever here, so that one's hidden while the lever's in its down position. You're going to want to move the lever up to get that out. Same screw positions as the left side. There's 3 connectors that are attached on this side. One of them's from the control panel, one's for the exit fan, the other one is for the door sensor switch here. And so we're going to have to unplug those. To do that, we have to access the connector panel in the electronics module. There's a cover here. I've already removed it. It's 1 screw that's right here, and that just pops off. The connectors we're looking to disconnect are the display connector, which is the very bottom gray ribbon cable. There's a toroid on it, and we're going to want to pull that out of the way. And then the connector is just like a connector in a computer. You push both ends of it and it pops out. The other 2 connectors are the bottom 2 on the extreme left. The black and the red, and the blue and the white. And pull those out and get them loose. With all the screws removed, and this will just also slide right off. Now we do need to get the ink tube system off of the carriage. So what we do next is just remove it completely from the machine. This is the other end of the ink tube system right here. It's actually on the carriage. It looks like it's part of the carriage, but it really isn't. The first thing you're going to do is push it over to this section where this door is. Open it up so that you can remove all of the print heads. Now, I've already removed the print heads to speed things up here a little bit. And then what you want to do is push this back down to about here. Now, there are little finger levers on both sides here. You squeeze in on that and you pull straight forward. Before you do that, there's a button up on top. I think we're going to want to get a picture of this. Okay, what we're going to do is get a close-up on this. Oops. That's it. Okay, once the button is pushed and this is moved over to the left, push both of these and just pull the assembly forward, and it's free of the carriage at this point. What we need to do then is push the carriage back out of the way so we can just move these, get the tube system out. And feed the tube system up between the frame members here. It's a little wider on this side, so you bring it down this way and bring it up and out. When you get to the blue portion here, it's not clipped in, it's just sitting in some slots, and that lifts right out. And there's the entire tube system. We'll be putting this back in a bit. Next thing we're going to do is remove the trailing cable. Trailing cable is this cable you can't see at the moment, but this is the trailing cable right here. Plugs into the carriage, carries all the signals between the carriage and the electronics module. So, see if I can arrange this so you can see it better. These are rather delicate connectors, and you just want to get on each side of it and gently pull them out. These are pretty easily damaged, but usually a damage in putting them in, not taking them out. Then we can press down on the keeper here and pop it out. It's not exactly popping easily. There it goes. And it's free. This is the stiffener. Make note of the position of that, because when we put it back in, that's about where you're going to want it. We can adjust that easily after it's in, but for now you just slide that out. Now you usually pull the trailing cable all the way out flat, let it hang out the other end of the machine just to protect it. Okay, now we need to undo the encoder strip here so that we can take this off, and then the whole carriage will slide out of the machine. I'm going to use one of the sockets that's in the kit. Remove this nut, which is already gone. Okay. This is a piece of spring steel here, and it's already flexed to keep the encoder strip tight. So I'm going to push in on that and just lift that off. Now this does need to come off of here. so that we can get this piece off. So we'll just set this aside. One screw holding this on. That's right here. Remove that. Now, getting the belt off is much easier at this point. You just unhook it from the pulley on the other end of the motor pulley. Putting it back on is a real trick, unless you compress the spring. Now, you can see here that this spring is fully in charge of tensioning the belt at this point. So the purpose of this brass screw is to compress that spring. We're going to compress it down to where it's a solid. Do not go beyond that because you'll break the part that the screw goes into. So just get it down to where it's a solid, completely compressed, and that should give you plenty of slack to put the belt back on when we're ready. Good enough. Now, on the motor end, just lift it off, nice and slack, and it'll push the idler pulley out of the machine. Take it out. This will come off at that point, and the carriage is ready to come off. Slide it right out. And that's all there is to getting the carriage out of this machine. Stop. Okay, we've got the carriage off here. This has a new belt on it, but the belt goes through a channel right here, and there are teeth on this portion that match up with the teeth on the belt. So you just basically pop it off and slip it off, slip a new one on. Now you do want to keep in mind these splices need to be in this range right here. They're much smaller splices than the HP, but nonetheless, you still need to keep them in close. What will happen is, if it gets far enough out, if this splices out too far, it'll bump into either the motor pulley or into the idler pulley. So you want to make sure that the splice is opposite this. It's going to be on the same side as the cutter. That's pretty important, otherwise you're going to be bumping into the pulleys. So we're ready to put this thing back into the machine. Tell me when you're going to go. Okay, we're ready to put the carriage back into the machine now. This bearing goes on this rod first, and the belt on this side goes between the rails. You slide that in, and the back bearing is spring loaded. You're going to push in on it slightly to get it lined up with the back rail. And then it should just slide in pretty much right from there. Okay, we're ready to put the tensioner assembly back on. Okay, next we're going to put on the tensioner assembly. That's one screw holds that on. So we'll put that back in. And we want to get the belt, just run that through here and bring it through because we're going to pull this pulley back in. I need to push the carriage down a bit to make sure the belt's not twisted. And in this case, it is twisted. So now we untwist it. Okay, we'll feed this through. And we'll put the pulley in the belt, match it up with the ribs on the belt, and pull it into the slot here. And now we're ready to put the belt over the motor pulley, which is the next thing. Generally, I would do this from the front, not the back. But I don't want to be in front of the camera, or between the camera and the machine. And just slip it right over. There's plenty of slack there to do that. Now we need to tension the belt. And if you remember, we compressed that spring. We're going to just back that brass screw out until it's doing absolutely nothing. The spring is calibrated and designed just to tension this. So we're going to back it out and let the spring do its job. And maybe you can see that spring beginning to decompress. Back the screw out until it's loose. It's a captive screw. It's not going to fall out of the machine. Now it's done its job. We're done. The next part is to put this encoder strip back on. The lug obviously goes to the outside here. Fits back into the machine with some little pegs. And we'll do just the opposite of what we did when we took it off, and that's compress that and put it on. And there's a nut that goes on here, which I have misplaced. We'll get to that in a minute. You need to look down through the machine and make sure that the encoder strip is completely vertical the whole way down and in properly. Now, a real important thing here, a lot of people make a mistake right at this point, and they get all confused later. This is the encoder strip sensor. The strip has to go through that sensor. Many times it'll be on the outside, or it'll be like that. And as soon as you power it up and the thing's going through its power on reset, the carriage jerks and it says, check paper path. Well, it's because a scan motor motion command was sent, and it's looking for immediate feedback from this. And if it doesn't get it, it shuts it down immediately. It thinks there's an obstruction. So make sure it's inside the sensor, not behind the sensor. Very common mistake. Okay. Next thing we're going to do is put the trailing cable back in. Generally start out by putting the tensioner in. It's going to be somewhere in that neighborhood. Make sure that the rest of the cable follows the tensioner. You're going to inspect these for any kind of damage. If they're bent back or missing, if they're bent, you can usually straighten them out with your fingernail. If you're very cautious, you can get them in. And if they're missing, or they're crossed over and you can't straighten them out, the trailing cable has to be replaced. You just don't have any other options. This isn't a real brilliant design, but I don't have any control over that. So I'm just going to very cautiously put these in straight down. Make sure they're all lined up before you put any pressure on, because these will peel off the plastic with any excuse at all. Okay, now I'll put this in the restrainer here, like that. And there's a cover that goes on, but I don't see that up here. It's a minor thing at the moment. Okay, next thing we do is put this tube system back into the machine. Procedure for putting in the tube system is exact opposite of the way we took it out. The blue little clip. This retrainer slides in there. Put the tubes into their channel here. where they normally live. Feed this down between the frame sections. And I'm going to open this again, and this just snaps back into position, just like that. And the part on the top, you're going to have to go to the wider part here. Wider still. And clip that in. Okay, we're ready to calibrate the machine. We're going to do the advanced calibration. That's short for paper advanced calibration. It matches the movement of the paper precisely to the movement of the carriage. In other words, we're matching X and Y axes. I've loaded the piece of plastic media that comes in the kit. I've loaded it in such a way that curl side is down. That means the proper side for printing is going to be facing the print heads. I've told the printer that I was loading a roll, even though it's just a long sheet, and I told it that it was production photo gloss. That'll lay down the proper amount of ink for this calibration. Okay, when the printer's in a ready state, we're going to go to the printer icon, which is printer setup menu. Hit enter. We're going to scroll down to utilities and hit enter. Once we're in utilities, we're going to hit the up arrow and enter. I'm sorry, no we're not. I think we just hit enter. Yes. And accuracy is right there, the third item down. And we're going to hit enter. Now it's going to ask if you want to restore factory. No, we don't. We want custom. We want this to be as good as it's going to be, so we're going to hit recalibrate. We're going to create the pattern and hit enter, and now it will print the pattern, cut off the sheet, and then we'll reload it. So we're going to take a break here while this is printing, and we'll be right back. Okay, well this is printed. Oops. And as you can see, it's got arrows down the one side. We're going to push the buttons here some more and tell it we want to read this pattern now. I guess we can unload this. Let's set that aside. Okay, same routine. We hit enter, utilities, calibrations, accuracy, recalibrate. Only this time we're going to measure the pattern. Hit enter. Okay, we've got to load it, and it's going to be a sheet, and enter. Okay, now I've got to go through the procedure of loading the sheet. Now the arrows are going to go in first, and they're going to go in face down from here. I'm not going to load from the top. That's an option, but I'm doing it this way. And you can see that the arrows are coming out first there. So you get it lined up on the blue lines and all. That should be close enough. And now it will load the medium. And with a little luck, it'll be straight enough, and it will read the medium. Once it reads the medium, it does some internal calculations, stores the information on the EEPROM, and that's the end of it. It's finished. You can go straight into production from there.